Good morning. Thank you for having me here. It's a tremendous honor for me to be able to do this. I asked in July for the smallest, latest slot possible so that I could talk about some DevOps things, and they decided to give me the keynote. So the last shall be first, I suppose. It's very humbling to be here. Many of you in this room taught me what I know. So it's a little bizarre for me to be here talking to you. But I appreciate the opportunity. DevOps is a huge shift in our industry. And the funny thing is, it's nothing new, right? That's one thing I've heard from a number of people here talking last night and this morning. What's new about this thing? There's nothing really new about it. But there is this catalyst. And it's an interesting one. It's one I want to explore and talk about some of the things that influence it, and some of the ways that we want to approach it. My real intention here is to try and shape the conversation that's going to occur here at LISA over the next couple of days. Because the most important thing that happens here at LISA is not what happens in these rooms or on this stage. It happens out in the hallways. It happens out in front of the building. It happens down in the bar. It's the conversations that we have, because that's what influences what we do when we go back to our companies, when we go back to our homes, the projects that we work on, the things that we create, the people that we talk to, the conversations that we have. So I really want you to be thinking about this and how it's going to influence the kind of discussions that you have with your peers while you're here. So what is DevOps, right? I think everyone has an idea. Does everyone have an idea of what DevOps is? You have your own idea in your mind of what it is? The accepted definition, there is no single definition, but the one that we all tend to agree on within the DevOps community is the one provided by Adam Jacob, which is that DevOps is a cultural and professional movement. And after this, he would say, that's it. So we're going to dig into that. What it is not a tool. It is not a thing. There is no tool that can be labeled DevOps. There is no product that can be called a DevOps tool, contrary to what many believe. And it is not a title. It is not a person. No one in this room is a DevOps. I am not a DevOps. Patrick Dubois is not a DevOps. No one is a DevOps. It is something that we do. And most importantly, it is not just Dev and Ops. Now, at a conference like Velocity, where a lot of this discussion occurs, it's very easy to say Dev and Ops, and everyone's pretty happy. There's a couple of QA people who end up there and go, hey, what about me? But by and large, it's Dev and Ops. But particularly in this community, this is why I'm really excited that this conversation is now happening here at LISA, is there's a lot of us that are enterprise people. I had my roots in enterprise. I plan to go back to enterprise in the future. And there, it might as well have been called DBA Ops. Right? I spent a lot of time just interfacing with DBAs, with QA people, with testers, going nowhere near developers who worked on websites that had nothing to do with websites. But these principles still apply even in those environments. So Patrick, as he put in his, I borrowed from his login article this month, star DevOps star ops star. John Willis has a really nice acronym that he likes to use to describe DevOps, which is CAMS. Culture, automation, measurement, and sharing. And that pretty well sums it up. So I'm done. Or maybe not. Personally, when I listen to DevOps talks, when I talk with people, when I'm at conferences and discussing DevOps, what it really comes up to, the image conjured in my mind is that of a banner of change. This is the picture I found on Flickr that was available. But I tend to think of a knight on a horse with a banner leading an army of people. It is a great banner of change. The number of topics discussed within the DevOps kind of movement are far-reaching and broad, right? Just about anything you could possibly want to talk about can be put under the label DevOps. So it really is a cultural banner of change. It is a word that conjures an idea, and that idea can be empowering just about anything. To a large degree, this is really about re-envisioning the IT world. This is one of my favorite scenes that had a huge impact on me when I was a kid. I believe it was Veruca Salt licks the wallpaper and says, "Snosberry, who's heard of a snosberry?" And Willy Wonka famously replies with what is actually an Arthur O'Shaughnessy quote from 1874, "We are the music makers and we are the dreamers of the dreams," which is a beautiful quote and tends to sum up quite a lot in quite a short space. The point is that the world is made by men. We can change this world. The ideas that we have were invented by other men. And by men, I mean the human race. We have the ability to change these things. And in the theory of constraints, Goldratt talks about inertia, right? One of the biggest problems for continuous improvement tends to be inertia. People just get used to doing something. The status quo sets in, and we just keep doing it. And at some point, we forget that we made it that way in the beginning, and we can change it. So kind of a pro tip number one. DevOps is a journey of discovery, not a destination. You will never hit some point where you're like, right on, we're a DevOps shop, right? That's the whole idea of continuous improvement, continuously improving. And please, it is an ongoing conversation. None of these definitions are nailed down. If you can come up with a better definition than what Adam Japek came up with, we will use it. The conversation is changing all the time. All right. So I like to deconstruct DevOps into, this is my version of CAMS, is it's about the collaboration of people, it's about the convergence of process, and it's about the creation and exploitation of tools. And it is in that order. It is not the reverse. And to explain this, I really like Simon Sinek's Golden Circle. He did a TED Talk about how great leaders inspire action. And in it, he provided this model, which is really fantastic. He uses it to explain why we love buying just about anything from a company like Apple as opposed to a company like Dell. If you look at, well, let's look at the next slide. The why corresponds to motivation, values, belief. The next layer out is the method. And the next layer out is what you do. So why you do it, how you do it, and what you do. And this actually, he says, maps to the layers of our mind. In the outer layers, in our neocortex, we have rational thoughts and language, and we get interested in features and specs and all these sorts of things. And as we move into the limbic brain, which has our feelings, behavior, decision-making, and has no concept for language, which explains why certain things feel right and certain things don't feel right. And when somebody says, well, why don't you like Emacs? It just doesn't feel right. Why isn't it right? I don't know. I can't tell you. It just feels wrong. It's that why, right? I didn't say whether I was an Emacs or a VI user. And I think that Bill Joy would think it's hilarious that we still have these debates in 2011. So it's a beautiful, nice little model. You think about a company like Dell. We know what a company like Dell does, and we have an idea of how it does it. But not a lot of us would really say that we know why it does what it does. Whereas a company like Apple, we know exactly why they do it. Think different, right? Radical change. They happen to make iPods and iPhones and computers, but we really latch onto that why. And when you want to latch in to really connect with people, you have to get into that limbic brain. You have to really attach why. So if we take something like the Golden Circle and apply it to DevOps, we start with why. We start deep about collaboration through quality through collaboration as a motivation. That's our driving motivation. We know why we want to do it. And we're going to worry about why and how as consequences of that. Right? We move out to how we do it. We use process and tools. And what do? We build awesome services, whatever that service is. An internal service, an external service, a website, whatever. And the reason I like this model is it shows precisely how DevOps can go horribly wrong, and you will be endlessly frustrated with it. If we start with what of automating with configuration management, which is fantastic, but then we start moving out in, right? So how do we do it? We build process around automation. And then what is our motivation? That comes later, and that tends to be something like improving efficiency of infrastructure management, which is awfully boring and nobody cares about, right? That's the sort of thing that you get all excited about. Then you take a vacation, come back, and you can't even remember why you did it in the first place. The Merovingian from The Matrix, everyone remembers that? It's one of the best speeches ever. There's so much packed into that speech. And he speaks to this with why is the only true source of power. Without it, you were powerless, right? The whole rant against Neo that the Merovingian posed was that Neo comes wanting the keymaker, right? Why do you want the keymaker? He says, we want the keymaker. That is not a why. That is not a reason. The keymaker is a means to an end to do what? They didn't know. Right? We can have that same approach with DevOps, right? We can know what we want, but not know why we want it, and end up with a real shock in the end. Or just never hitting the goal whatsoever, and it just kind of peters out and falls on the floor. This is the difference between the people you see are looking at DevOps and kind of think it's really very interesting, but they don't really know what it's going to do for them. It's because they're focused on the what, not the why. There's a second model that's really important to me, and it shaped a lot of my thinking in a lot of different areas. This is generally applicable, but I'm going to use it here. A guy named Dr. Russell Ackoff, we'll talk a little bit more about him later, describes the 5 contents of the mind, which he says are data, information, knowledge, understanding, and wisdom. It's a hierarchy. When you break that down, data is just raw data, the number 12, or 42, right? Information is who, what, where, how much, the reporter's questions. Knowledge is how to. Understanding is why. And wisdom is insight. Wisdom is when you can look at a situation and without even performing the experiment, have an idea what the outcome is ultimately going to be. And there's a variety of different uses for this. This is something I end up drawing on my whiteboard all the time because I just see it again and again and again. It's just sort of marked on everything. One of them is to understand our own place in job hierarchies, right? If you think about somebody who's in like support or a junior SA, they got a lot of information, maybe a little knowledge, and not a lot of the higher stacks, right? And you get into system administrator, senior system administrators, systems engineers, those of us that are here, right? More knowledge, understanding, and wisdom. Somebody who has a lot of wisdom, the old senior administrator who's been around for a long time, right? You might call an architect, is more towards that wisdom category, right? This sort of explains to me, one of the things that it helps with me is, you ever have like a sales guy who comes and blurts out a couple of words, and instantly they're just the right words, you kind of panic like, oh, what does he know? Is he going to get into my thing, right? They've got information, but they don't have the knowledge. They don't have the understanding. They don't see how all those pieces fit together. They've just gotten a couple of blurbs, and they're now regurgitating that to you, right? Which frustrates us all to no end, right? A number of executive decisions get made based on information without knowledge. And if you kind of can actually break this into two different sections, knowledge, information, and data analysis, right? This is what children do. This is what we do most of the time. This is what we got really good at in the Renaissance, of taking something, breaking it into its constituent parts, playing around with the constituent parts, seeing what they do, building it back together and going, aha, I have information, I have knowledge. But when you get into understanding, it's not so easy. You need to understand the why. The why is systematic, right? You have to look at the whole system and look at the components of the system and look at the interactions within that system, right? This is this kind of area of doing synthesis is one of the reasons with complex software, sometimes we can really get into a bind. We just don't understand how all the parts work. We can rip it apart. We know what all the different parts of the software do, but there's still some part of us that just doesn't understand why it is that way. Why did you do it that way? And I won't name names because many of the people are in this room. So a lot of times, just talking to that person, asking some questions, fills in those gaps, and we now have a more systematic view. When we really get to understanding, as we get more experience, that gets uplifted into wisdom. Systems thinking is a very, very useful thing. After all, we are system administrators. And one of the things that really changed for me a couple of years ago is I had to think about my own title. I'm a systems administrator. What is the system? Is it a sun starfire? Is that the system? Or is it 500 boxes in a data center all doing roughly the same thing? Which system am I thinking about? So there's this whole field of systems thinking which is concerned with this interaction of the parts to form a whole. And when we try to build complex infrastructures, we're generally doing that, right? We're taking all these different components and we're building them together to the point that they start to blur. We're very interested in the whole picture, in a systematic view. This is what tools like Nagios give us the ability to do. A lot of the configuration management tools now are giving us a better ability to do, is to stop thinking about individual boxes and start thinking of systems in a much more broad context. There's an additional field called system dynamics, which is really concerned with feedback loops between the parts. And that gets a lot more mathematical, but is interesting. And systems thinking is something, if you haven't spent time studying this in the past, I'd recommend you pick up a book at some point and just start to familiarize yourself with the topics. A lot of the history, we'll get into a little bit of it later, is concerned with ecosystems and those sorts of things. Dr. Deming made an important statement once that a system cannot understand itself. A common example is that if you look at a car, you can examine the car all day long. Nothing will tell you why you drive on the left in America but on the right in Britain. Like, there's no part of the car that will explain that to you, right? A lot of us understand why, but that's because of the fact that we have an understanding of the system. So tip 2. DevOps starts with why. It starts with a holistic vision, and it supports that vision with process and tools. But we always start with why. So looking at dev and ops itself, right? This is the way the model should be, right? There should be this seamless overlap. What they do is obviously intertwined, and it should be like this, right? Naturally. But it's not. It's like this, right? It's a bunch of silos. And so you got dev and ops, and you got DBAs, and you got designers, and you got QA, and they're all these different silos. And it doesn't make any sense, because if you look at the value stream, it looks more like this, right? We have business requirements coming in. They go into dev. Dev produces software. Software is fed into operations, which then, as I like to say, weaponizes it and turns it into a service. Right? They build the warhead, and we build the ICBM. But we have these siloed priorities, right? If you look at it, I mean, anybody who's read any kind of business books in the past knows that the way that you approach producing a good and the way that you produce a service is very, very different. Software is essentially a good, right? They write the code, it gets splatted out. We treat it as a good. It's then fed into ops, which then produces a service, right? But the priorities in these two different siloed groups is very different. It's what tends to keep them siloed, right? Dev is interested in getting it out on time, reducing defects. Ops is trying to keep it up, get it up, and do it cheaply, and generally with understaffed. Plus, in the ops side, we have all these non-functional requirements that we have to deal with, right? All the not fun stuff that we get to do that nobody else really thinks about but is essential. And if anybody wants to hear my NFR rant, just ask during questions. So who's responsible for quality in this model? Both, right? In their own way, but they're different aspects. In order to talk about quality, you got to ask, well, what is quality? And I don't know if you guys have ever looked at like the real hard definitions of quality, but they suck. They suck, right? Quality was one of the primary concerns of the business world throughout the 20th century. And these are the best definitions they got. The best one comes from ISO 9000, which is the degree to which a set of inherent characteristics fulfills requirements, right? Dr. Duran, he had a famous bow tie and funny head. Says it's fitness for use. Crosby, another quality guru, says it's conformance to requirements. Six Sigma, which is awfully boring, says it's the number of defects per million opportunities. Does that seem like any definition of quality you've ever internalized? They're awful, which is funny. You read all these books on quality, and they never define it. And it's like, I missed a page. A page is ripped out of my book. Where did it go? But when you look at these definitions, is it any wonder that we had waterfall for so long? It shocks me. So many people look, and they're like, waterfall's awful. I can't believe we ever used that. Why did that happen? Well, if it's the degree to which a set of inherent characteristics fulfills requirements, you better spend a lot of time figuring out what your requirements are so that you can fulfill them. Otherwise, you don't have quality, right? The idea of doing this iteratively was like, well, why would you do that? You need to know exactly what you need to produce before you produce it, which is why quality in the 20th century took over everything. The thing at the end of the assembly line went to the front of the assembly line because they realized they were building the wrong thing in the first place. So what is quality really? I like to say it's the degree to which a good or service is what the customer expects it to be. An example would be like a Big Mac. Is it a great burger? Probably not. But you expect a Big Mac to be a certain way. And when it is that way, you say it's a quality product, right? My favorite is Velveeta. Velveeta, is it quality cheese? No, it's awful. It's not cheese. It's oil in a can. But many people have come to, for whatever sadistic reason, love cheese in a can. Is it quality cheese in a can? Yes. So, you know, if that's what you're into, it's perfect. So quality can change based on what your expectation is. And my favorite is something like steak. What is the quality of steak? The best you can say is it's a measure of its steakiness, right? A steak that makes you re-envision what a steak is, you're like, that was a quality steak. I like that. That was good. That was a quality steak. One that feels rubbery, doesn't taste like beef, things like that, it's not what it's supposed to be. It's inherently not what you expected. And it doesn't exceed your expectations. So what is quality software? And I'm taking this from like an end user's perspective, like what all of us would generally expect from software. Well, first of all, it should do what it's supposed to do. It should be intuitive and easy to use. It should be quick and responsive, given the task. If you're transcoding something, it's going to take a while, but you expect that. And it should be observable, right? When you click to open a new tab in Firefox and your Mac gives you a spinning beach ball, and you're like, was it that hard? What's going on? What are you doing? Right? You want to have a sense of what it's doing, right? You bring all those together, and you feel like you've got a fairly quality product. When we look at a quality service, it's pretty much the same list of things, actually. Because of the fact that we're an enterprise group, we deal with service desks and stuff, too. I'm adding in that easy to use should also mean friendly if there are human interactions involved. But we have two additional components, which is availability and increasingly today, self-service. People don't want to wait in line. They want to be able to self-service if possible. And so Peter Drucker had this statement. How many people have seen this before? A bunch? About half? Okay. Where he says efficiency is doing things right, and effectiveness is doing the right things. And this is something I'd encourage all of us to have plastered on our walls, because it's a good question to ask. How often, when you're working on something, are you actually focusing on efficiency? You're making it better. But are you doing the right thing in the first place? Should you even be doing it? Russell Ackoff actually did a number of different extrapolations of this, who said that if you're doing the wrong thing but improve the efficiency, you actually become wronger. Not righter, wronger, right? So pro tip number 3. Quality is a result of effectiveness of the interactions across the value stream, right? We can't really ensure quality if these two things are separate and we measure quality differently in these two different silos. We've got to look at the whole value chain as one seamless entity and look at quality across it. The Agile Manifesto, everyone's read this, right? And if you haven't, please lie. But ponder it. And if you haven't seen it in a while, remember that what it says is that while both things are important, we value the things on the left over the things that are on the right. So we're interested in individuals and interactions over process and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and response to change over following a plan. And ever since this was introduced, there was this real attempt by a number of people to try and bring this over to the operations side with very little success. One of the things that really hindered Agile in the early days, many of you may recall, is actually one of the things that's hindering DevOps right now, is that when people thought Agile, they thought in the early days XP, extreme programming, and then Scrum. Like Agile is Scrum. No, it's not. Scrum is something that can help you become Agile, but Scrum is not Agile. Just in the same way that configuration management is not DevOps. Configuration management can help you move in a DevOps direction and move towards those ideals, but it is not inherently. So what are the advantages of Agile, right? It's non-prescriptive. It's a simple philosophy that really became an umbrella. There was this tidal wave of different of things that came out of this movement of Agile. It applies both to the developer and product management alike. It's widely known, and it's really easy to grok, right? You don't have to think about this long before you're like, there's a lot of sense in that. Maybe I agree with it, maybe I don't, but I can understand that. I can see where they're coming from. What was the solution that we had? Somebody already cursed ITIL. I'll school you in just a second. IT service management, right? We had things like the control objectives for information and related technology, otherwise known as COBIT. CMMI, ITIL, we had a bunch of ISO standards which proved that you did the earlier things like 20K, 27K, 38.5. And then we've got a bunch of various best practices and control frameworks like NIST SP 853, PCI DSS for credit cards, FIPS 200, TIA 942, which is actually an awesome read. You should read it. And it makes no sense. It's really mind-boggling. Now, this is one of the things I want to admit to you. I created this out of my head based on my understanding, and I have thankfully, the Lord has been good to me. I have never worked in a company that actually had to do Sarbanes-Oxley. So some of you who have done big SOX implementations are probably looking at this going, that's all wrong. But if you never have, this is eventually what you piece together after months of trying to figure it out. And what's funny is that when you read Sarbanes-Oxley, as I actually have, it doesn't tell you much except you need to have internal controls and tight controls. Okay, so that points off to something called COSO. You look at COSO and it says, here's some general ideas, but you really need to have a control framework. But it doesn't really tell you what to do. So you end up going with a governance framework like we have in the middle here with like COBIT or ISO 38.5. And that gets prescriptive. Okay, this is what I'm supposed to be doing. And you start doing that, except that it doesn't really tell you how to do all the different components within it. So you go off the best practice. And you've got ITIL and PMBOK and Prince2 and ASL and BISL and just on and on and on. Then you've got the security controls on the other side, ISO 27K and SP 853, PCI DSS, and FIPS 200. And then, of course, you've got to prove that you're, in fact, doing this. So you've got ISO 20K to prove that you're actually doing ITSM and 38.5 to confirm that you actually have that. And then a lot of times we audit this with SAS 70. And SAS 70 is hilarious because SAS 70 just says that you do a comprehensive audit of controls. And actually, it's not as prescriptive as most of us believe it is. Because when you hear SAS 70 type 1 or 2, all of us have something that pops into our head of, okay, they're going to come and check the doors, and they're going to make sure backups are running. SAS 70 just says that you do an audit, right? The auditors have decided to add a lot of the rest of it. It's a mess. What are the problems with it? It's compliance driven. Most people who know anything about it at all only know about it because they've gone through compliance. It's highly security focused. It's complex, it's complicated, and it's bureaucratic, all things we hate. It's pushed down generally from the top, and it's on an already overburdened staff. We got plenty of things to do. Great, now I get to do this new thing. That, of course, just encourages this huge community of consultants, which if you're one of them, good for you. The rest of us kind of sucks. It's almost impossible to grok. And because of the fact that the standards are either free and complicated, or they're expensive and hard for people to get, everyone doesn't read the actual standards. They read a book about the standards, so you have all this second and third-hand knowledge. Very few people have actually gone through and read all of it. But I do want to single out ITIL. If you hate ITIL, raise your hand. Okay. If you love ITIL, raise your hand. Brave soul, brave soul. You're on the fence. Okay. So now here's a question. If you've ever read the actual 5 books, not a book about the books, the actual 5 books, raise your hand. Okay, those are the same hands that actually said they liked it. So cool, thank you for confirming an experiment that I had no idea was going to work. ITIL's fantastic. It is absolutely fantastic. If you don't like it, I want you to think very much about why you don't like it. Find me in the bar and come and tell me why you don't like it. But I'll imagine it's probably because it's been pushed down on you from the top and made bureaucratic. And the thing is ITIL is a bunch of best practice. It is a huge hodgepodge. It's a gigantic FAQ. For those of us, the reason I got interested in this, because at some point I stepped back and went, I know how I'm doing it. I know how others have done it, how we've run an IT shop. But what's it supposed to look like? What's the golden rule? What's it really supposed to be? And I didn't have a good model. And when you ask people, how did you make it the way it is, right? It's all very anecdotal. Nobody has a really good explanation. So ITIL provides a lot of those answers, right? It's 5 books. It costs like $500 if you want to buy the real deal, but it is worth it. ITIL does provide a lot of advantages. It is the most complete and respected pattern for IT. It is the source for a lot of the ideas most of us now believe is just common sense, and we've always done it this way. Things like change management, event incident problem management, CMDB. I will say one thing that I loved when I started looking at ITIL is that I used to call everything an issue. In our ops team, everything was just an issue. So this issue, that, and they're not separated. So just having this common terminology of separating issues into requirements fulfillment, events, incidents, problems, and those sorts of things was fantastic. And now I can talk to other people. We have a common language. And it's chock full of good ideas. So why reinvent the wheel? And what's even better is if you want to be re-educated on the awesomeness of ITIL, there is a session on Thursday, which I'm not part of, but I'm going to go to. Now, for those who like the ideas on ITIL but don't like ITIL itself, there's, of course, Visible Ops, which is a fantastic book. When I first read this book, I just picked it off of Dr. Jason Hoffman's desk one day while I was waiting for a meeting and just was blown away with the wisdom contained inside this book. It takes ITIL and crams it down into a way that's much more palatable and easy to digest. And if you haven't read it, you should. Who's read it? I highly recommend it. It's like $30, and it's a quick read. It's fantastic. But here's the funny thing. If you look at it, it's a bunch of books. It's just a stack of books. And it's funny because on one bookshelf I have all my old RPGs, right? I'm a Palladium gamer for any of the gamers here. So, I got Rifts and Robotech and all these, role-playing games. And the shelf underneath it, I've got ITIL and all these ISO standards. And it's sort of like, it's just a bunch of rules. And it's the similarities are incredible, right? It's a bunch of rules that help you play the game. But anybody who's ever played role-playing games, and if you haven't, I know a lot of people like to play at night, so come get educated. The rules don't make the games fun. The rules just provide a framework in which human beings, can interject their own ideas and get a fun, interesting world. In RPG terminology, the DM makes it fun, not the rule book, right? And people who are too restrictive to the rules, you get a bad game, right? It's just a bureaucratic, boring game. Very much so the same with all these ITSM standards. So ITSM is something that we have a very weird relationship with in operations today. It's something that I would really like to see in this decade to get sorted out. No ideas should be rejected. We need all the help we can get. So let's take them. But don't view it as all in or all out. You don't have to accept it all. The people who hate ITIL a lot of times, they adopted things that they never should have adopted. Take the bits that are good and use them. Reject the bits that are bad. Reevaluate them later. But please do educate yourself on them and know that they're there. And maybe you don't need them today, but in the future when you do, you know that it's there as a resource that you can pick up. Many of them are free. ITIL is expensive, but if you are going to get into ITIL, please, please, please buy the books. Don't buy a book about the book. Just buy the book. Last thing on this is I did a blog post on this a while back called Ars Gratia Artis, art for the sake of art. This is a famous piece of art, and it is a urinal. And the contour of the porcelain is very pretty and all that, but that wasn't the point. The point is it was actually a commentary about the art world at the time. Now, if you're not an art lover, there's just a toilet. The problem here is a lot of times when we go and implement things, whether it's Agile or DevOps or ITSM or whatever, when we implement it simply to implement it, we end up only making sense to a very small group of people. And you may get a lot of props within that small community, but ultimately you're going to have to band together because nobody else understands you. So we all know, as administrators, we all know intimately the evils of implementing things just to implement it, right? When your boss tells you, go and get the latest new tool because it's awesome. And you're like, no. And he doesn't understand, but it's awesome. You should get it. So pro tip 4, Agile and ITSM are both sources from which to draw strength, but never at the expense of your original vision. I'll zoom through this. Cloud definitely changed the game for all of us, right? The way I kind of look at it, on the IT side, virtualization stops being about consolidation. That was a big change. Remember when virtualization came along, it was all about consolidation. All the vendors were telling us it's all about consolidation. And instead, it changed over to being about self-service, automated infrastructure, without all the bare metal constraints, right? It moved our concerns as administrators up stack if we adopted it. Another interesting one, is particularly in the context of Lisa, is remember how we used to love HPC like 10 years ago? A lot of the talks here were about HPC. We were all very interested in what was going on in the HPC space. And now I could care less. I'm way more interested in what Amazon's doing, Facebook's doing, what those of you in this room are doing, way more than HPC. So that was an interesting shift. The role of the OS has definitely changed. Old OS wars, my OS is better than your OS, is almost silly because I can boot any of them anytime. So a lot of those discussions have changed. And it really has helped, at least in my case, I think a number of people's cases, give us this broad platform standardization. You can now standardize all your hardware, right, as opposed to having 17 different Sun servers and 14 different HP servers and IBM servers. They're all hodgepodged. So I think virtualization has been fantastic. But on the development side, things are a little different. Cloud has really allowed dev to bypass IT, right? I'm probably the only person who's ever seen this. I'm sure none of you ever see this. But I can tell you as a cloud provider, I've seen a number of customers come along and fire up applications, and we actually would flag them as abuse, like somebody's marauding as company X. Can't believe that. We need to shut them down. And just before we shut them down, we go and talk to the customer. They're like, no, don't do that. It's cool. It's cool. But you look like a phishing site. Nah, the internal IT guys suck, so we just decided to go with you on a private credit card. Like wow. I know how I would feel if I was back at your employer. It is happening. Maybe you know about it, maybe you don't. Another problem is that a lot of the dev guys, when cloud first came along, I know there's one of the concerns is that the dev had a lot more experience with the APIs that were being used to control these things than ops did, right? So all of a sudden we're at an immediate disadvantage. And cloud really has been a great leveler, right? Anybody with an idea can now get the infrastructure. There's no ramp up time, there's no colo concerns. Anybody can be a player. And also from the dev side, Scrum, continuous integration, a lot of the different things that have come out of Agile have really sped up the rate of deployment, which really increases the demands on operations. And so rifts have formed. You see this particularly if you look at the kind of rifts that have happened at the discussions that happen at Velocity that start looking very different, like, ooh, what's going on over there? Migration services, things like this. A lot of the transition over from cloud to cloud and virtualization has had advantages, but also caused a lot of strain. And the tools have rised up to solve the problems. And there's some real advantages here, right? We've seen an explosion of tools that have been propelled by this. Build your own cloud solutions, whether it's proprietary, like from VMware, whether or not it's commercially backed like Joyent's SDC, or OpenStack, right? There are a lot of great solutions now available. Infrastructure as code starts looking really realistic, thanks to a lot of the tools like Puppet, Chef, bconfig, CF Engine, et cetera. And a lot of the SaaS solutions have been fantastic. I don't know how many people have you started using PagerDuty, but like that, I love it. PagerDuty is great. So there's a lot of operations-focused software as a service offerings that just are wonderful for things that, frankly, I don't care about, upgrading and all that. I don't want to deal with that. Ticket systems, Zendesk, things like that have been great. Vagrant is a piece of software that was created by Patrick Dubois. And what it allows you to do is... Oh, that's right. Sorry. Viwi. But talked about by Patrick a lot. Vagrant is a way of controlling local virtualization using VirtualBox. It's really fantastic for taking a lot of the work that we're, if you're automating your infrastructure, you can apply that kind of pattern into VMs. So you can have a developer spin up test dev environments on their laptops. You can reuse that. And that starts to really bridge a lot of those gaps. What you're doing in production can now be applied into dev and really helps a lot. So cloud is here to stay, and it's awesome. And I think one of the real concerns early on was that, this is going to be the end of SAs, right? We're all going to be screwed. And it's only speeding things up, and it's going to continue to do so. It's going to continuously increase the demands for SAs, but our concerns are going to continue to move up stack, right? What's interesting now is you listen to a lot of the new operations people, and they'll say things like, I've never been in a data center, right? Which I'm an old timer, right? I kind of look at it like, it's scary. But it's happening, right? The things are changing. So here's a topic. Has anybody ever taken an operations management class? Any? Couple? Are you bitter? This is something I think we're going to start tackling a lot more in the coming decade. Operations management is defined by Wikipedia as operations as an area of management concerned with overseeing, designing, and redesigning business operations and the production of goods and or services. It's exciting. So what is operations? In the classic management context, a company is divided into 3 different sections: finance, operations, and marketing. And if you're saying we're sales, they consider that part of marketing. So operations is doing what you do. And the kinds of subjects that are addressed within operations management are things like strategy, products and service development, project management, process measurement, financial analysis, quality management, forecasting, weight line theory. And this is where we get things like Lean and Six Sigma. They all fall into this category. And what's funny is that this is sneaking up around us all the time. These concepts are being injected, particularly under the name Lean, are being injected all around us in education, in healthcare, in the business world, in operations. But we don't generally know all the terms, and we don't know where to look. So we're feeling this stuff, and we're seeing this stuff, and we don't know what's kind of this ivy's creeping up around us. And so I want to give you a brief history of operations management, because then I can say everyone at Lisa knows the history of operations management, and it will be kind of awesome. But it's slightly going to bore you, so I'm going to go really, really fast. But the point here is that a lot of the things we consider common sense weren't. They're recent inventions through the 20th century. It's been said multiple times before, common sense is never common. So I want you to see where some of these concepts that come through, because most people, when you talk to them, you say, where did that come from? They're like, oh, it's just common sense. Everyone knows that. They haven't always been. And the rate of change throughout the 20th century is just amazing. So, Frederick Wilson Taylor, he wrote a book called The Principles of Scientific Management, Applied Scientific Method to Work, back in 1911. So in 1911, this guy was telling people how much to put on the end of their shovel and when to sit down and how to work efficiently. This hasn't happened. It was amazing that it wasn't that long ago that this started. He just generally blamed for everything because he was considered a jerk. Nobody really likes it when a guy stands there with a stopwatch and decides how you do things. But he was trying to apply the scientific method to daily work and did it quite successfully. And with him and a number of others, what's funny is you'll look at that and you'll be like, what an awful guy. He's just lording over people and telling them how to do their work. But he was really concerned with them being efficient so they could be paid more and work less. This was in a time when people were making very little money. And they were working extraordinary hours. Henry Ford, father of mass production, right, built one car for a very long time. But it's funny, when he introduced the Model T in 1908, it cost 20 grand in today's money. And when he stopped making them in 27, it was 3K. It's an incredible reduction for essentially the exact same car. You just got better and better and better at making them. The kinds of changes the kinds of innovations that you see that Henry Ford came up with in his plants, which came to be known collectively as mass production, are really incredible. He wrote a lot of books. I recommend taking a look at them because of the changes that were going on at the turn of the century that Henry Ford is addressing are very much like the concerns we're dealing with in operations today. The parallels are incredible, but I won't bore you with all of them because this is bad enough as it is. Alfred Sloan. He did for management, big management, what Ford did for the factory itself. He gave a bunch of money to MIT, his alma mater, and you can go see his building across the way. Toyota, you notice it's with a D, not a T. They later changed the name from Toyota to Toyota because it's devoid of meaning. He actually started out a loom work. And the cool thing about Toyota that's really fascinating is the way he started was when he was a little kid, he would watch his mother and his grandmother sit there spinning yarn. And as they were spinning yarn, every so often the thread would break and it would feed through the machine and it would take forever to pull everything back out and wire it back in, right? Just like a geek seeing, a geek teenager seeing a problem, going, oh, I think I know I can fix that. He's mechanically minded and he came up with what later became known as Jidoka, autonomous automation, which is he figured that he could put a little pin in there so as soon as the thread snapped, it would stop. It did nothing more magical than that. The machine just stopped. But the advantage is you didn't have to undo all this work, right? It's like early fault management. Fantastic. He took that technology and started his own loom works in 1927. Eventually, they decided to make cars. Other ideas he came up with are 5 Whys, which is a central part of Lean. We'll get back to the Toyota story in a second. Shewhart, he worked at Bell Labs from 25 until he retired in 56, because why would you ever leave Bell Labs? It's Bell Labs. He is the father of statistical process control. I tried to explain Shewhart to my wife once, and I said, when you walk out of a bathroom and you see a chart with last check, that was Shewhart's fault. A lot of you have probably heard of PDCA, which is the continuous improvement cycle used in just about everything. It originally was PDSA, and invented by Shewhart as the continuous improvement cycle, which is plan, do, study, act. It was later changed to plan, do, check, act. And the funny thing is he's a stats guy with a PhD in physics. Almost all these people are EEs and physics guys. Almost none of them are actually statisticians. Deming is the big guy that most people have heard of. He was a student of Shewhart. Most of his ideas were basically him trying to convince the world that Shewhart was right. And the funny thing is Shewhart didn't get the glory Deming did. The PDCA is often known as the Deming cycle. The funny thing is Deming never called it that. He always called it the Shewhart cycle. He was sent to Japan. He did work on census. He went to Japan after World War II to help with the Japanese census. While he was there, they were like, we really need somebody who's a master in statistical process control. He started teaching classes and subsequently won basically every award you could possibly win in Japan. I mean, honor from the emperor and the whole deal. He really became known as the father of the quality movement, and he was ignored in the US until the late 70s. And he also had a BS in EE. Then you go to Taiichi Ohno. This is the guy who actually was credited as the father of the Toyota production system. And the Toyota production system is known today as Lean. He created it in the late 1940s, refined it in the early 1950s. And all this happened when World War II ended, and the president of Toyota said, if we don't catch up to American production within 3 years, Japan is screwed. So get to work. The toughest situations produce the most interesting solutions, right? And Lean, which we're all doing now, is a result of that crunch. He's the father of just-in-time and Kanban, and he learned most of his tricks from Henry Ford and from Deming. So you see his chain, all these different elements, right? Ford was working with Taylor. Ohno was taking in from the kind of geek tendencies of Toyota, and the things that came out of Sloan and Ford, and you see this continuous chain evolving, and it's just kind of snowballing forward. Shigeo Shingo was the technical man behind TPS. He was the father of something called SMED, the single-minute exchange of dies, which is when you're producing a car, you got a bunch of machines, and it takes a long time to change the dies from one machine to another. It would take hours, in some cases days. And Ohno really wanted to create this very flow-based, very quick system, which was called Kanban, became known as just-in-time. And the idea there was that you only made the parts you actually needed. And the problem is when you're only going to make 5 parts and it takes an hour to set up, you're screwed. And it's funny, it's the same sort of problem we have now, right? Doing provisionings of bare metal systems in some cases can take a long time, right? So what do? You batch them all together, right? You batch as much of it as you can. So he came up with this method called single-minute exchange of dies, and that's less than 10 minutes, single-digit minute, not 1 minute, that allowed them to quickly switch over the machines from one to another, and then they could stamp out 5 parts and switch it over to another, make 5 parts, and only produce what they actually needed. He also created a method called poka-yoke, mistake proofing, and that led to something called zero quality control. And the ideas that he has are really fantastic. I mean, configuration management has essentially been the SMED of our industry, right? Now setting up a new server isn't as hard as it used to be. You just apply all of your recipes or your cookbooks into that environment and bam, off you go, right? We've had all these ideas for change management that have been really hard to actually implement. We look at what we can do with configuration management. Suddenly, it's all actually very doable. So there's a lot of parallels there. Ohno has said that if it weren't for SMED, Kanban would have fallen dead on the floor. It never would have worked. So it always takes that technical component along with the idealistic. Poka-yoke is something that's funny to look at. This is Israel Gott had this shirt, which if you can read it, says Poka-yoke your boss, which I thought was funny. Poka-yoke is a very simple idea, though. He would basically design things from the beginning that only fit together in one way, right? So that you didn't have things that were put together backwards at the end of the assembly line, right? Designing in that kind of tolerance from the beginning. They would do similar things to what Ford would do, where they'd just build little grooves into the decks of certain machines where you just slide the part off into the tray, and if it fit, you're good. And if it didn't, you keep going. There's all kinds of different ideas based on the work that he did that we can apply. Peter Drucker is the father of modern management. He wrote 39 different books on management between 1939 and 2005. And a lot of the things that are considered common sense he wrote about. Most of your bosses are schooled by this dude and they don't even know it. Bertalanffy, which I still can't pronounce, is the father of general systems theory. He actually wrote all this stuff when he was in Europe, but nobody really paid much attention to it until after World War II. He came to the New World, translated it all into English, and it just took off like mad. And Russell Ackoff is a friend of Deming's, pioneer of OR, which is taking operations management, turning it into a bunch of mathematical formulas, and then optimizing your business on a piece of paper, generally the size of a house, and making it work. But he's a hilarious dude. I think he's like the Feynman of OR. And a lot of his talks, he did a lot of talks in the 90s, which you can actually find on YouTube. So go and watch him. He's hilarious. And he actually has a BS in architecture. This guy is the person who actually came up with total quality control. Everyone heard about TQM through the 80s and the 90s, and trying to find out who's actually responsible for that mess. Turns out it's actually this guy. But all his ideas actually came from Deming and that train before him, and ultimately got codified in ISO 9000. And he's a PhD in econ, which is why he's horribly boring, but it's from MIT. The funny thing is there was all this work on how you should run a business, how you should run assembly lines, all these efficiencies that came about, and nobody in the US cared until the 1973 oil crisis, which dealt this horrible blow to the US mass production system. Because they're churning out thousands and thousands of cars, and all of a sudden nobody's buying cars because of the oil crisis, and they're just still coming off the end of the assembly line, and nobody knows what to do. Thanks to just-in-time and Kanban, where you only build what you need, the Japanese production system just stopped, and they stopped making cars. And when people started buying cars, they started making cars again, and they rebounded. U.S. mass production companies didn't. They were just spilling cars onto the floor. And so Japan weathered that storm, thanks to the Toyota production system that by this time had been used across Japan. In the 80s, it just got ramped up. Japanese quality put ours to shame. And the funny thing is that Deming, who started this whole thing through Japan, wasn't even known in the US until NBC, of all people, did a documentary on why the Japanese are kicking our butt in 1980. All of a sudden, his consulting business goes crazy, and he actually starts writing books in the US in 83. And then you end up with a number of things that happen after this, where there's all these ideas, but they haven't been assimilated into the American culture. And so people like Dr. Goldratt come up with the theory of constraints, which sort of builds on this continuing line of lean thinking and gives us some really fantastic ways of approaching problems. And he decided that nobody likes reading business books, and nobody actually reads them, they skim them. So he decided to write a novel instead called The Goal, which is interesting. You should totally read it. It's a good book. And it's the kind of book that it goes through a series of problems, and you're part of that transformation. So for us in operations, I think it's a fun book to read, because as you're reading it, you'll start seeing parallels to things in your own shops, similar problems that you have, and it's interesting to see how they're worked out. He applied TOC to a number of different areas, such as project management, and called it critical chain, applied it to sales and called it the mafia offer, the offer you can't refuse. And then James Womack and co. in 1988 wrote an HBR article about Japanese quality, because everyone was very fascinated in what was going on. And that's where the term lean comes from. He didn't want to call it the Toyota Prediction System. He called it lean. Published in a 1990 book, The Machine That Changed the World. The point of all of this, because I know you all came to Lisa going like, I can't believe I'm going to learn about Ford. It's going to be fantastic. Is that so much of what's around us and the ideas that are being pushed on us and the things that we're being expected to do are from a bunch of people who had their own problems and solved them and shared that knowledge. All these guys wrote books. I have them all. Thank you to Joyent for expensing all of them because they're expensive. But it's funny, as I've dug into that world, I've lost myself over the course of the last year because there are so many parallels to what we're dealing with today. Lean will continue to push in on IT over the course of the next couple of years, if it's not already digging into now. And that's not a bad thing. There are a lot of great ideas. But like I said earlier with things like ITSM, the important thing is that we fully understand the concepts that are being pushed on us so that we can use them in the ways that they should be used, rather than just buckling under the pressure of upper management telling us to do something without fully understanding the why. Why are we doing it this way? Does it really fit into our vision as a company? And a side benefit is that almost all the OM pioneers are geeks. Like, seriously, they're all geeks. The way that you're really seeing this being pushed right now, and this, if you're wondering why this is part of the DevOps thing, one of the big pushes within DevOps is the Lean Startup. Another is a book called Lean IT. The Lean IT book is great. If you don't want to read all the books of the guys that I told you about, just read Lean IT. But these ideas are coming through, and they're not new ideas. These guys are just taking Lean concepts and applying it to all sorts of daily things. So the real point here is if you can't remember your history, you're going to repeat it. We're going to go through the same cycles that operations management people went through in the last century. If we don't learn from them, we're going to reinvent all of that. And we're going to pat ourselves on the back for doing it, but it's going to be a big waste of time. Okay, last section here. A while back, I came up with what I call the 3 aspects of DevOps. When you're talking to people about DevOps, particularly at conferences like Velocity, where there's equally devs and ops people, here it's not as big an issue. You can get very confused. What are you talking about, right? We're all talking DevOps, and we're talking about different things. So I decided that I remembered I had this problem actually with SCSI a long time ago. Remember when somebody say, like, we're getting a new SCSI tape drive, and you're like, great, I have all the cables you need. And then he went, oh, it's differential. And you went, shit. Who uses differential? High voltage differential sucks. And you remember how we solved that with SCSI? Is the SCSI logo actually was slightly different for each different variant, which is funny. I didn't know that for a long time. And all of a sudden I went, oh, that's why that line's there. So I thought, let's do the same thing here, and I can break it apart and think about it. So the first is what I call dev into ops. This is an ops-centric view of DevOps. It adopts infrastructure as code as an ideal. It considers things like Scrum, Kanban, Agile operation concepts. It starts to get really serious about metrics and holistic and qualitative monitoring. This is where most of us are today. Almost every one of you who are here today, this is where you're at. You're trying to take things from dev, from Agile, and try and bring them into your ops group. You're really thinking about ops, okay? The next is ops into dev. This is a dev-centric view where they're getting into things like continuous deployment, they're embedding metrics, and they're becoming more and more operational themselves. But again, this is dev kind of absorbing ops. And then you get here, which a lot of people like that I call this Tanagra in my blog. This is, which there's a lot of wisdom in that episode of TNG. You should watch it. You know, Dharmak and Jalad at Tanagra. Right? But it's funny, but I mean, it's a classic tale. The reason that was a good episode, why most Star Trek were good episodes, is they're built on old mythologies, right? Ancient truths. And a shared conflict is a way to really build synergy. So this is where in this model, we're interested in full collaboration of both teams. Boundaries between the two teams blur, really adopting a one-team feel. This is one of the places where you give dev access to the prod environment, which people always say root. Holy crap, we have our back, people. We have our back. So, use ACLs. Let dev people into the production environment, but don't give them root. Like, seriously, does anybody not use sudo or RBAC? Okay, if you do, other people here will educate you. And one of the symptoms here is joy. Now, here's the thing about transitioning is, while I look at these as three different aspects, you can also look at them as a phase transition of going through it. But don't, please. Please, please, please don't. The way to do this is to start directly by bringing dev and ops together. Bring the two groups together and start solving problems from the beginning. Don't go off and figure out what you're going to do in ops so that you can get your DevOps strategy figured out, and then go into dev and talk about how maybe we can integrate them, and then ultimately bring the teams together. Start from the beginning, learn together, just like that TNG episode. If you can't do that because you're so insanely siloed you can't get out of it, then you can do what you need to on both sides, set the stage, use lots of metrics, and then build a management case to bring the teams together. But does anyone know what the most powerful tool in the whole DevOps arsenal is? He does. I already know he knows. Beer! It is. Right? And it's no different. We've been practicing this principle every night here at Lisa, and we will again tonight. Beer and chips, beer and chips, beer and chips. So if you really want to start DevOps, the way to do it is not to go out and get a new configuration management tool, especially if you're not already sold on it. Take the dev team, take the QA team, take the ops team, take them down to the bar, buy them a bunch of drinks and a bunch of chips or fries, and just let them talk, right? I doubt they're going to talk about sports the whole time, right? That's the way to start this process. It's not any more complicated than that. It's all about collaboration, and it's just bringing these two people together so they can start solving their problems. It's that simple. The other tools to get you started are things like office hours. Office hours is a really easy idea. If you have a chat channel, IRC, Jabber, whatever, for your company, you can set up a time, whatever you want, once a week or something, and say, during this time, there is no such thing as a dumb question. Anyone can come, anyone can ask. We'll share information, no problem. And you will get dumb questions. You may have a sales guy who goes, what does LS do? And that's not a dumb question. My general view of dumb questions is, if they have to ask a dumb question, you're dumb for not helping them come to the answer before. Another way to do this is to just physically move the teams together if you can. Let them sit together. Another way is join each other's meetings. Go and listen to a dev scrum or whatever in the morning and see what their problems are and see if you don't have solutions. A lot of times we have ideas for these people, and vice versa. Ask lots of questions. Implement the no asshole rule. This is actually based on a book. This is not me saying this. There actually is a book called The No Asshole Rule, and I recommend you read it. It's a fantastic book. It applies widely. And have fun. If it ain't fun, it ain't working. Ultimately, this is one of the most important concepts here is with this collaboration, there should be a return to a pride of workmanship, right? The book of Ecclesiastes says there's two things that are good in life. One is just taking pride in your work, and the other is eating well. So really, we should enjoy the work that we do. We should take pride in the work that we do on both sides. We should be having fun. So this is sort of a sum-up slide. Collaboration of people, convergence of process, creation of and exploitation of tools, measure everything as you go, have a systems view, focus on effectiveness and quality, learn from others and the past, because there is a lot of it there, and encourage pride of workmanship. Have fun. We should like what we do. We're all here because we love what we do. I doubt anyone got drugged here against their will. And if you did, we'll buy you a couple extra rounds of beer tonight. Just thank you.
Ask people to use the microphones.
Okay. How much time do we have?
And not to use the center aisle.
I encourage questions. If you want to ask questions, come up to a mic. They're on the sides. Don't stand in the middle because there's a camera. And I would, this really is about a conversation. So feel free to ask questions, not just of me, but of each other, so that we can continue to discuss this. By the way, all these are awesome people. If you want to really start getting around the energy of DevOps, look on Twitter. Start following any one of these people and just see who they're talking about, and you'll get kind of sucked in. Go ahead, Mark.
Ready? Okay, thank you. Mark Burgess from CF Engine.
Everyone knows you, Mark. You're the man.
Oh, thank you. No, today you are the man. I think this was a fantastic talk, and thank you so much for paying attention to history, looking back through these great thinkers of history, because I think there's a lot of things to be learned from this. It's fascinating to me because I've also been blogging about this kind of thing recently on the CF Engine website, using Alvin Toffler's notion of the 3 waves of society from...
Toffler's fantastic, isn't he?
Isn't he fantastic?
The things that he talked about back in the 50s and 60s about the rate of change, it was incredible. That's what they were dealing with in the 50s.
He was
and
40
now we don't
years
even
ahead of
see
his
it.
time. 40 years ahead of his time.
It's incredible.
I encourage everyone to read Future Shock, The Third
Future
Wave.
Shock. Read Future
Fantastic
Shock.
books. But I mean, his point was we go through these phases of society from manual labor through large-scale industrialization to the information age. And in the information age, which we're sort of creeping into right now, we're trying to get away from mass industrialization, where we made everything the same, one size fits all, any color as long as it's black,
Right.
the Henry Ford era. And it strikes me that that DevOps is one expression of this desire to break away from mass industrialization, where people basically worked for the machine. Mm-hmm. People became parts in a machine, making everything the same, responding to alarms and tickets.
Yeah, Charlie Chaplin's famous 1937 film Modern Times, where he gets sucked into the machine. And It's funny because what's funny about that film to me is mass production hadn't been around that long. It really was, it was still kind of in its infancy, and society already hated it.
So what do you think? I mean, is DevOps one expression of this desire to participate in a freer expression, to make a difference in a world that will be ruled more by diversity than, everybody working for this monolithic machine-like industrial process?
Yeah, absolutely. I think that the technologies that you largely kicked off, thank you, Mark, are making it possible to do what we've always known we were supposed to be doing. Right? I mean, there is nothing new here. Absolutely nothing new here. We've always known that we should be collaborating. And the funny thing is a lot of us in this room have tried and been shot down. There was a number of reasons for that. One is that the tool base just wasn't there to make the collaboration easy. Another is we talked about priorities of the different groups were different. I think at this point, after 15 years of the web, I think we're all now comfortable enough with what it is that we're doing and how it's supposed to go. I think we're finally moving past that, how do we build the assembly lines, how do we build the factories, to really being a lot more focused on what's actually coming off the line and going out the door. And so a lot of old ideas are coming new ideas over the course of the last 15 years and over the course of the last century.
Thank you so much for a really inspiring talk. And do come to my talk this afternoon.
Go ahead, sir.
I'm Stephen Levine. I work as a technical writer at Red Hat. And early in your talk, you mentioned that DevOps is about more than dev and more than ops, and you brought in QA.
Yes.
And I would just like to make a comment bringing in technical writing. To which 30 years ago, a technical writing colleague of mine developed what she called the tectonic plate theory of technical writing, similar to your silos. And the way she described it was you have development is one tectonic plate, and in those days, marketing, although now we might even say operations, certainly the users. And they were different plates, and when you had to document a product and bridge the plates, you had Mount St. Helens. And
Right.
so technical writers were the Mount St. Helens of the field. So when I'm listening to what you're saying here about the collaborative process and the interactive process and the working together from the beginning and the lack of in-siloization, I'm thinking this could address one of my lifetime issues of trying to be a technical writer, because they've always been so separate, and often the place of fault line is the documentation.
Oh, I
And
absolutely agree.
So if you're starting here,
I've always thought it was amazing inside of large corporations. I love technical writing. I almost decided to go that way for a couple of years just to do that because I love it. And what's funny is even in large companies, like I saw this at Sun all the time. They didn't exist, so I can badmouth them. Their technical writers would actually sit there, and they basically had administrators who would hack on the software, figure it out themselves, and then write the manuals. I'm like, how is that any different than any of us in the community doing it? It's not at all. One would think that they would be sitting there next to the guy who wrote it and going, what were you thinking about? What was in your mind? What are you really trying to do, right?
Those are the whys of your
They're
golden
not.
triangle.
It's crazy. And support inside the corporations is even worse.
Right,
So yes, absolutely. I mean, all these groups should be together. And it's common sense, but no one's doing it.
Well, we're going to start.
Exactly. One more question.
Actually, more a comment and observation. Thank you very much. I was very pleased to see operations research and operations management make it in, because I'm with the local group here in Boston, Back Bay Lisa. At the last meeting, I actually brought up my own SMED moment of actually swapping out an entire Postgres database under our running applications in exactly 9 minutes. Whereas before, it used to take us over an hour to an hour and a half. We'd have disruptions of the service. This was, terrific. It's like, SMED? Isn't that something you get on the bottom of your shoe or something? Is that? And the question is, not only if we fail to know what went on before, we'll end up reinventing the wheel. The problem is the second time it gets reinvented, it usually gets reinvented poorly.
Right.
And the question is, how do we get our bosses and other people to understand that operations research is not some foreign concept? It really pertains directly to what we do. Because this is, I've been promulgating Lean and Six Sigma and operations research and ITIL for a while, and I get, oh, you don't know what you're talking about.
No.
It has no meaning whatsoever.
The problem's more fundamental than that. We don't know it exists. That's why I'm talking about it here. No, you know how I learned about operations management? I was at church, of all things, walking my child, and it turned out somebody had donated an operations manual to the church or whatever, right? And so I'm sitting there with my baby, rocking her along, and I see this book, Operations Management. I'm like, holy crap, that looks totally like, what is that? And I flip it open, and I see the table of contents, and I'm like, I've been asking people about this stuff for years, and nobody knew where it came from. Nobody knew what it was. I'm like, I took this book home and just like devoured it, and then proceeded to buy every other textbook I could. And I'm actually going to go over to MIT Sloan to look through their library tomorrow. I didn't know it was there until I fell across it in the weirdest possible way.
Actually, the most appropriate way. Learning operations management is almost like getting religion.
It is. It is. Yeah, and don't get me started on that line. But so one of the most important things here is like, I believe, particularly with the issue of sysadmin education, every sysadmin, I think everyone who goes through a CS course should be forced to take an operations management course at some point. Because what we're producing is services. And we need to know the history of how you produce services, not be told how to produce a service, but not how to actually do anything with it. And it's a perfect thing for college, right? It's the class you should take, hate, pass the test, and forget. So that 15 years later, when you have a problem and you're like, how do I deal with this? You go, oh, I remember operations management. Exactly. But most of us don't even have that knowledge. So that's why I felt passionate about bringing it to Lisa and sharing it. It might have bored a bunch of people, but now one day you're going to be like, oh, I know exactly where to go to look for that.
One of the things that was also great was actually seeing pictures of the people whose books I've been reading over the years and whose names have been coming across the thing. It's like, oh, that's what the guy looked like. Okay, cool.
I have a very complete library, so we can swap.
Oh, cool. Sounds like a plan.
Thank you.
Thank you.
Thank you very much.